Okay, shout out to Hunter for asking this question, so you can high five him. All right, so it talks here, it says the list stages of actresses that won Academy, Best Actresses, and then actors who also won Best Actor. So this is who's that dude? This is the age of the actress, okay, that won Best Actress, and this is the age of the same year. So notice it says these are matched, and that's important because you have to know which test you're supposed to use. All right. So what I'm going to do first is I'm going to set up my hypothesis, where my hypothesis, the null is always equal. Always. The null is always equal. If it equals 0, that's saying if I subtract these values, there's no difference, okay, in their mean differences. All right, here it says to use a sample, blah, 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 blah. The differences have a mean less than 0, so they're generally younger. And I do that bad boy right there, and I hit check answer, and woohoo, well done, Cindy. All right, now it wants me to find the test statistic, and it tells me this is a T, but again, I have to realize this is matched data. So I open this up in StatCrunch because it's way easier to use it in StatCrunch. And you notice I clicked on the side there so I don't have to type all the values in. I go to Stat, I know it's a T, paired. Okay, so matched and paired means the same thing. Sample in first column, my actresses, then my actors. And notice here, okay, my hypothesis, I just have to be careful that I select less than. And I hit compute, and it gives me my T-stat right here, negative 2.73, looks like rounded. Negative 2.73. Excellent! Oh, I did such a good job. And now it asks me for my p-value, which is in the same place. So rounded 0.012. 0.0, oops, I'm typing, but it ain't working. 0.012. Woohoo! Excellent. All right, what's the rule? If the p is low, the null must go. So since the p-value is less than or equal, ooh, wait, what's our significance? 0.01. 0.01. So that's actually a little bit, not a lot, but a little bit greater than our level of significance. So if the p-value is greater than the significance level, we cannot reject the null. Even though it's just a little, it's enough, okay? So in other words, we cannot say there's enough evidence to support the claim that actresses are generally younger. If your p-value was less than, then you would actually reject the null. And then you could say that they were generally younger. All right, now I will tell you, and this is why I'm glad Hunter asked this one, I had one earlier, and that's why you see that big old ugly red X. That was 0.05, and I did a 95% confidence interval, and it didn't work. I ended up having to do a 90% confidence interval, so that's kind of a quirk, I guess, with this problem. But I'm going to assume 99%. So let's see if that works. So what I do is I just go back and I open up my StatCrunch. I go to options. And notice here the confidence interval. Just leave everything the way it was. And again, with the level of significance, I'm going to assume, we'll see what happens, that they're asking me for 99%. Why? Because 0.01 was the level of significance. So I compute and I get negative 21 point, how many decimal places? One. Negative 21, let me put this over here so I can see it. Negative 21.3 and 1.9. So let's put this back over here so you can see where I got those numbers. So the lower limit and the upper limit. And say a small prayer and you get it wrong. All right, this looks to me, okay, so if I look at this, the only thing I can assume, and so we'll try this. Remember I told you when I had 0.05, it actually wanted me to do a 90%. So what I would suggest, since this is a confidence interval and this is one tail, notice that's what this is saying. Remember, a confidence interval is two tail. So what you really should be testing, is 98. Why? Because 2 times 0.01 is 98. Now I get something a little different, negative 19, put this over here again, negative 19.7 and 0.3. Again, let me bring it back so you can see where I'm getting these numbers. Okay, so 98%, because we had to multiply the significance by 2. And then I check this and I get it correct. So this is why you might be getting this wrong, at least the confidence interval part, because your hypothesis test is one tail, confidence intervals are two tail. All right, remember the rule with confidence intervals, does this contain 0? Think of a number line. If you went from negative to positive, you definitely went across to get 0. If the confidence interval contains 0, and you should get the same result. Okay, so in fact, whatever you got up there, you should get the same result. Then you simply fail to reject. So again, thanks for reaching out and asking this question, and I hope that helped.